Good afternoon, everyone. We are going to work with solving systems of equations today, and we're going to do it the easy way today. We're going to do it with Desmos. But first, we probably should talk about what is a system of equations. So we're going to do some preliminary stuff here first with what is a system of equations. When we hear that phrase, system of equations, what are we talking about? All right. Well, a system of equations for our purposes is just two equations considered at the same time. That is the simplest definition I can give you about a system of equations, is that it is two equations considered at the same time. All right. And so, for example, maybe they give us y equals 3x minus 4 and y equals negative 1/2 x minus 2 or something like that. Two different equations that we're talking about at the same time, okay? They're not always going to both be in slope-intercept form. The two that I gave you are in slope-intercept form, but they're not always going to be in slope-intercept form. So the big thing that we're concerned about today is, what is a solution? The solution to a system of equations is the point. And when we talk about a point, we're talking about an x coordinate and a y coordinate. Okay? It is the point where they intersect. That's all it is. Okay? So when we do this with Desmos, Desmos tells us the solution instantly. And it is super fast and super easy. We're also going to have to learn how to do it algebraically, but I want you to understand the graphical meaning first. Basically, you know, if I graph these two equations that I gave you, I'm not going to graph them formally, but the first one goes through -4 and it's kind of like that, and the other one goes through -2 and is kind of like that. This point right here where they intersect would be the solution. All right. And we're going to learn how to do it graphically with Desmos. And in another day, we're going to learn how to do it algebraically as well. So let's do a couple examples real quick. But before we do, I also need to bring up this situation. What if the lines are parallel? If the lines are parallel, that means they don't intersect. If they're parallel, there is no solution to the system. Okay, so if you graph your two lines and they're parallel like that, then there's no solution. All right. One other situation. The two lines could be the same equation, but maybe you can't tell it when you graph them. What do I mean? If the two equations are the same, there are infinitely many solutions. And I'll give you a quick example of a system of equations where there could be infinitely many solutions. One like this, y equals 2x plus 9, and 3y equals 6x plus 27. If that is your system of equations, when you graph them, they would graph right on top of each other. Because look at this second one. Do you see this second equation is just the first equation multiplied by 3? If I multiply y, 2x, and 9 by 3, I'll get this second equation. These two are the same. And so when you graph them, what would happen on Desmos is you graph the first one like this, and then when you graph the second one, it graphs right on top of it, just like that. And so they're the same equation, all right? Doing it on, finding our solutions on Desmos is easy. Let's do just a couple. Before I switch to Desmos, let me give you the two equations we're going to work with. You're going to be asked to solve graphically. And let's say that my system of equations is y equals 3x minus 4 and y equals negative 1/2 x plus 2. Now, when you do this assignment, I want you to include a quick sketch of the graph. All right, the graph does not have to be perfect, but I do want a quick sketch of the graph to show me that you did actually graph them on Desmos, because I'll be able to tell by looking at the graph if you're just scribbling something down. All right, so just as an accountability piece, give me a sketch of the graph. And so we go to Desmos now. All we have to do is type in those two equations. Y equals 3x minus 4. There's the first one. And then we type in the other equation, y equals negative 1/2 x plus 2. And Desmos is just amazing on this. All I have to do is hover over this point. And if I hover over the point, you can see that it gives me the coordinates of that point of intersection. 1.714, okay? Hover over the point, there they are. 1.714 is the x coordinate, 1.143 is the y coordinate. So on your paper, I would like to see a sketch of that graph. You don't have to spend a bunch of time on making it perfect. Obviously, this one went through -4. I can at least get that right. The other one went through +2. And so it's not as steep, but it's negative, okay? This one is the y equals 3x minus 4. This one is the y equals negative 1/2 x plus 2. And my point of intersection, the solution, according to Desmos, the x coordinate was 1.714. The y coordinate was 1.143. This is your solution. All right. And this right here, I'd like to see something like, just like I have on my paper, I'd like to see that when you do these problems tonight for homework. There's not going to be very many of them. And the only other thing I want to mention to you is that these equations do not have to be solved for y to put them into Desmos. I want to just real quick show you one more. What if I add y equals 2/3 x minus 7 as one of the equations, and 3x plus 5y equals 15 is the other one? And I wanted to solve that system of equations. You do not have to put this in y-intercept form before you put it in Desmos. Desmos makes this great, all right? All you have to do is put those in. I'll go to Desmos. Clear out what I had before. Put in my two equations, y equals 2/3 x minus 7, and the other one was not solved for y. It was 3x plus 5y equals 15. I just typed it in the way it was, and there's my point of intersection. Just hover over it, and it tells you what it is. See, if you move your mouse, it goes away. If you hover over it, it tells you what it is. Or you can just click on that point, and it will tell you what it is. All right? So on that problem, again, you would put a sketch of what you found out. I'm not going to spend as much time on this graph. They intersected down here someplace. And the solution was 7.895 for the x value. That's my x. My y is negative 1.737. And that's how easy it is to solve a system of equations in Desmos. Just remember, if they're parallel, there's no solution. And if it looks like when you graph them, they graph on top of each other, then there's infinitely many solutions. Remember that those are possibilities when you are solving these systems of equations in Desmos. And we will stop there for today.